All right, so we're on Journal 66, and now we're taking a look at writing this series in a summation notation. So remember that series are basically this sequence where instead of commas between the numbers, you have plus signs because you want to add all the terms in the sequence. Now, I'm not asking you to add these numbers up and give me a total. That is not what I'm asking. I'm actually asking for you to write it in summation notation. So that's using that Greek symbol, sigma, that we learned, which also means the summing of something. So we're summing up this sequence here. So to do that, we need first a lower limit and an upper limit. That's what we're going to need first. Okay. So take a moment to try to do this on your own if you remember how to do this from your previous journals. Also, you'll need to build a formula. I'll give you a clue here. To build that formula, you need to first look at the sequence and see what the pattern is. If you know what pattern it is, you might be able to tell if this is arithmetic or geometric. Then from there, you need to use one of those formulas that we learned for geometric or arithmetic to build a rule. All right, so pause this video for however long you need to try to figure this out on your own. And then when you figured it out or when you want to see how it's done, start the video again. Okay, so let me show you how you could do this. So first, I can look at this, write a sigma, and I can declare a lower limit. So I'm going to declare my lower limit to start at the term position 1. So I'm going to say n is equal to 1. Remember, you usually use a variable and then a number. So in this case, I'm saying like this here is my first position, A1. Okay? And then so next I would have A2, and then A3, and A4, and then it goes all the way up to the 5th position. So in this case, because I go up to the 5th position, this needs to be a 5 because I'm going to the 5th term. From there, I need a formula, okay? So my formula here, I have to look first at the type of pattern I have. So it looks like it's adding by 2, right? It adds by 2 every time to get to the next term. So from there, I can say that, well, if it's adding by the same number, this is arithmetic. And arithmetic means that I need to use that nth formula, an, a1 plus n minus 1 times d, the common difference. So the common difference here, since we've looked at this the sequence common difference is 2 because it's adding by 2. The first term in the sequence is 1 because that is the first term that I see here. Okay, from there I'm going to plug these two values into my formula to create a rule or a formula that's specific to this series. So if I plug that in, let's see what we get here. This would be A1, which is 1 plus n minus 1. D is 2. And then if I distribute this 2n, because I want to simplify this formula, I get 1 plus 2n minus 2. And from there, I'm going to combine any like terms I see. I see the 1 and the negative 2. If I combine them, I get negative 1. So this is 2n minus 1. From here, it looks like I can't simplify any further. So this here is my formula. But the only piece that I really want to grab from here is just this guy. I don't need the an. So that right there is going to go here. So this is going to be 2n minus 1. And there we have it. We have our summation notation where I have the lower bound starting the position at 1 and ending at the 5th term. And then my formula right here. Okay, so in the next slide here, we're going to try out figuring out how we can sum up a geometric series because we haven't learned that yet. All right, in this slide here, we're going to be talking about a geometric series. Now, in a geometric series, basically it means that you have this geometric sequence and you're just adding up the terms. So instead of adding the terms one by one, sometimes that would take us too long. So we have a formula built to take care of that. So in this formula, you'll need your first term. R, if you remember that in geometric sequences, that is your common ratio, or just ratio. N is your position, or how many terms you are adding, where S is going to be, or Sn is going to be the sum. So this formula should give you the sum of your geometric series. So looking at the first one here, you're given a series, and you need to figure out what your sum is. Now, here's the thing. I'm going to do this one by hand using the formula, and then I'm going to do this one using the graphing calculator. Okay, so that means if I want to do A by hand, I'm going to need to get, let's see, maybe how many n's I have, so how many terms I want to sum up. So if I want to know the number of terms I'm summing up, I have to look at my limits. So this starts at the 4th position and goes to 10. So if I'm starting at 4th term, I have the 4th term, the 5th term, the 6th term, the 7th term, the 8th term, the 9th term, the 10th term. That is 7 terms if you were counting with me. So 7 terms here. Now a quick way you could figure out how many terms you have is you take your upper limit and subtract it by your lower limit. So 10 minus 4 is 6. But then you have to remember, you have to add 1 to it to get the correct number, because oftentimes you're not counting the starting position when you count or when you subtract. So that's why I recommend either counting it with your fingers, how many terms there are, or taking the limits, subtracting them, and then adding 1. All right, we found our n. So now we might need to find our r, our common ratio. So I want you to really look at this formula here. It looks awfully like a geometric sequence formula. So that's going to be your n, a1, r to the n minus 1. When you look at this formula here, notice how the r, the base, is raised to the n minus 1. And notice that here, your 2 is being raised to the n minus 1. So that's telling me that this here is definitely a geometric sequence because of the formula that's in the summation notation. But the 2 here specifically needs to be my r, because this 2 is being raised to the n minus 1. And so that's giving me a dead giveaway that r here has to be 2. Okay, so from here, all I need to do now is figure out what's my first term of this series. Now notice how this first term of the series starts at the 4th term. So I need to find the 4th term, because that would tell me what my starting value is going to be. So my 4th term here, if I plug in 4 into this formula, that would be 2, 4 minus 1, 4, 2, so that would be 4 minus 1, which is 3. And then 2 to the 3rd power is going to give me 8, because that's like multiplying 2 3 times. And so 4 times 8 gives me 32. And so in this case, I have all the things I need to plug into my formula. So to plug this into your formula, I'm actually going to rewrite the formula. Actually, no, I won't rewrite it, because you guys can see the formula right there. So just follow me along. So the first term goes, so 32, plug in 1, r is 2 to the n is 7, over 1 minus r again. You have to plug in r twice, okay, so keep that in mind. From here, you might want to grab a graphing calculator or some sort of calculator, because we're going to be dealing with a few big numbers here. So I'm going to work on the numerator and denominator separately to try to simplify this as best as I can. So in the numerator here, I might want to figure out what 2 to the 7th power is. 2 to the 7th power is 128. So this would be 32, 1 minus 128. And the bottom here, in the denominator, 1 minus 2 gives me negative 1. Might need a scoot this a bit. Where did I get this highlighter in the way? There we go. And so from here, then I want to ask myself, okay, 1 minus 128 is going to give you negative 127 over negative 1. If you take a look here now, you have this denominator and you have this number here. So you can actually put this all in the calculator. So 32 times negative 127, divide that by negative 1. So I'm going to put that in the calculator. So when I put this in the calculator, I got a sum of, oops, my bad, 4,064 as my sum. And so this is what I get when I sum up all the terms in this series here. Okay, so that's how you do it by hand. You need to get an n value, the number of terms you're adding up, your common ratio, your r, and your first term in the sequence, and plug it into the formula. So it's not terrible. Then this one here, this one I'm going to actually use the graphing calculator so I can teach you another way you could solve this problem. So grab a graphing calculator here. If you don't have one, just watch, and when you get to class, try to see if you can do it with the graphing calculators in class. All right, so I'm going to turn on my graphing calculator, and I'm going to turn on my camera as well. All right, so I hope you can see my graphing calculator here. The lighting is not great, but hopefully this will do. So when you take a look at this series here, notice how I need that sigma notation, right? So if I'm going to try to get that sigma notation, it's our favorite button on the graphing calculator. It's math. Hit that button, and you're going to get a wide range of different stuff to choose from. But you want to scroll down all the way to 0 on this, so use your arrow keys, and it's there, the summation notation. Or a quick way to get here is just to hit math and then 0. So here I am, and notice now I have those summation notation. Okay, notice right there where you would put your variable, your k in this case. So instead of putting k, you're going to be putting x's, okay? So that variable button that you usually use that's next to the alpha button, you're going to use x's instead of whatever variable your problem is. So now we're going to put in what our lower limit is, which is 1. Our upper limit is 12. Oops, sorry, I pressed the wrong button. Let me get back to where I was. There we were. And so we have 12. And here I'm going to put in my formula. You see how by default it gives me these parentheses, right? So make sure you do not delete these parentheses when they give it to you. Inside this parentheses, you should have your formula in it. In other words, like you see how like our series right here, this is our formula. Pretend that the calculator gives you these parentheses. What you have to do is stick all of your stuff inside that parentheses, just the way it looks. And so that's going to be parentheses, -3, another parentheses, -5. Close that parentheses, raise it to the x minus 1 instead of k minus 1, because we're using x's instead. And there we have it. We have our notation inside the calculator. Now we're going to hit enter. And boom, we got our number here, our sum. So I'm going to take that number and put that into my answer here. That's how much we get when we add up all the terms. Okay. So now I'm going to take a look. Let me turn this camera off now. I'm going to put this to the side. So if you looked at our number there, that was 1220731 as our answer. And so that took me just a few seconds to figure out on the graphing calculator, so feel free to use that graphing calculator to help you out. All right, so you can do these problems in the graphing calculator. I don't mind. I just taught it to you both ways, so that way you know how to do it by hand if you don't have a graphing calculator at home, or you can do this if you're in class and you have one. Feel free to use my graphing calculators. Okay, so in this problem here, we're trying to find the first term of this geometric series. And so this time around, it's like I give you the sum, I give you how many terms we're adding up, and the common ratio. You have to figure out what the first term is. So the first term, if you want to try to get that, probably want to write down what our formula is for that sum that we had a moment ago. So this was the formula that you saw in the previous slide. Okay, we're going to be using this formula and plugging in everything that we have into the formula so that we can solve for the first term. So if I plug everything in, I have S, N, oh, but I know what S is, negative 26240 equals my A1, I don't know what A1 is, 1 minus R, R is going to be negative 3 to the 8th power. Now notice I put that negative 3 in parentheses. Really important that you do that, because if it's a negative number and you're raising it to a power and you're doing this on the calculator, you might forget to include that negative. So make sure you put parentheses around it or just plug it in the way you see it right here. 1 minus R, which is also negative 3. Now, when you take a look at this problem here, notice how like the A1 is the only variable left here now. I'm going to drop that down. This side here, the bottom, maybe I can simplify it a little bit better, like the bottom. 1 minus negative 3, that means that they're going to all change to plus signs, because when you have two negatives, they make a positive. So the bottom here is now a 4. Now, this part right here, I'm actually going to chug it into the calculator to figure out what that number is. So let me grab my camera. So here's my graphing calculator. When I plug this in here, it's going to look just like the way it looks like in this parentheses here. So it's 1 minus negative 3, notice how I have it in parentheses, to the 8th power, and I'm going to get my number. So in this case, my number here is that, let's see if I can turn off this camera, negative 6560. So that's my number here. Move this a little. Okay, so now I'm going to just work this part out. The other side here was negative 2624. So I'm just going to drop that down. And then from here, maybe I could divide, I'm going to divide this number with the 4 to see what that number is. So I'm going to take my graphing calculator, divide that by 4. I get negative 640, or 1,640. This side I'm going to drop it down. And so notice now this is the only thing next to the A1, and that's implying that it's multiplying. So I'm going to divide this number off so I can get the A1 by itself. So that cancels. And so A1 is equal to, well, let's see, I'm going to use my calculator to help me out. So I'm taking 26,240 divided by negative 1640. And that's going to give me, ooh, it's a nice number, 16. So my first term here is 16. Okay, the next problem here, I'm going to do it the exact same way as I did it with this problem. So I'm going to maybe move this guy a little smaller down here. All right, so this problem, I'm going to do it the exact same way, plug in everything I know, and then try to solve for that A1. So if I plug in everything, I have 59048 equals A1, which I don't know what that is. In parentheses, I have 1 minus r. R is going to be 3 to the 10th power this time, because n is 10. And now I'm going to put it over 1 minus r. R is 3. All right, let's work this out. So the bottom here is super easy. The bottom 1 minus 3 is going to give you -2. A1's on top. Let's figure out what that 1 minus 3 to the 10th power is. I'm going to do that in the graphing calculator. Now this time I'm not going to show you. Hopefully you know what to do at this point if you have a calculator. So if I put this in the calculator, I get -59048. And then this side here is still that 5048. And then I'm going to take these two numbers and I'm going to divide. So if I take that -59048 and divide it by -2, I get A1 2524. And then this side here, 59048. I'm going to divide both sides by this 29524 to cancel that guy out. So I have to divide this side by 29524. And that's going to give me, I'm guessing 2, because that's looks like the same number as before. But let's see here what the graphing calculator says. I also got 2. So this is 2 equals my first term. And there we have it, our answer. Okay, so in the next slide here, last example, I'm going to be showing you how you can find the nth term. All right, so in this example, we've done for solving the sum, we've done solving the first term. Now we're going to be talking about how you can find the n in your formula. So let's say you have everything else. So notice how you have the first term, the common ratio, and the sum. And so if I was using that formula, Sn equals A1, this formula here, all I have to do is figure out what my n is. Okay, so to do that, I'm going to still have to plug everything that I know in so that I can solve for that n. So to do that, Sn is equal to 59048. This is going to be equal to the first term, which I know this time. It's 2. And then we have 1 minus r. R is 3. N, I don't know what it is, over 1 minus another 3. And so now I'm going to work this out to try to simplify. So the bottom here, 1 minus 3 is just -2. The top, I have a 2, 1 minus 3n. This side here is going to be staying the same. What I could do here is, like, I noticed that there's a 2 here and a -2 here, and there's a line. So I can divide that number there. If I divide these two numbers, 2 divided by -2 gives me -1. And so now I'm just left with -1, 1 minus 3n, that stuff in the parentheses. This side here is 59048. So there's a few things you can do. You can divide this -1 over to the other side, or you could actually distribute this -1, which I'm going to do. So -1 times +1 is going to give you -1. -1 times -3n is going to give you +3n. All it does is just flip the signs. And then this side here, 59048, bring that down. I'm going to add 1 to both sides. That's going to cancel, leaving me with just 3n. And this side here, 59049, if you add 1 to both sides. All right, now this is the tricky part. How do you get this n off of the exponent? Like, how do you bring it down so that this 3, the base, goes away? Well, we learned a long time ago, if you want to figure out what the exponent of a base is, we use logs. So to use logs, we have to, so if we want to use logs, we first have to figure out, okay, what's my base? Because the base goes in that small subscript here for the log, so that tiny number. So the base here is 3. So that's going to be a 3 there. Then inside your log should be the number you're trying to get the value of when you raise it to raise it to a power. So that's going to be the 59049. And then this here is going to equal our exponent, in this case, n. Or if you want to use the heart method, you could do that too. Basically, you need to write this 3n on the left-hand side. If you do your heart, you write this as log. Notice how it starts at the 3, goes to this number, and then it goes to equals n. And you would get like the same thing that we wrote here. Now, all I need to do is figure out what this is in the graphing calculator to do log. So I'm going to use my graphing calculator here to help me out. So let's see here. Let me see if I can turn on my video again. So here's my graphing calculator. I'm going to turn it back on. Remember, if you want to use logs, you have to hit this button, math, and then you go to log base. It's right there. And notice now when I hit enter, I can put in my base, which is 3. And this is 5904, 4. Type that in right. Let me double check. That looks good. I'm going to hit enter, and I get 10. So that means that n is equal to 10. So grab my pen, and it's 10. So that means the number of terms to add up to get to this number here is 10 terms. All right, that's it for this journal here. So this should help you out with page 4 of the packet 14. So now go try out those problems. You can do those by hand, or you can use the graphing calculator. I'm fine with both.